This video is on acids. We're going to look at the Bronsted-Lowry definition. There are several different definitions. This is the one we're going to use exclusively in this class. An acid is an H plus donor, and a base is an H plus acceptor, also called proton. H plus is a proton in both cases. So you'll hear it said H plus donor or proton donor, or sometimes just hydrogen. Hydrogen's wrong because that implies an electron. And so we're going to just look at one acid right now, strong acid, HCl, and I'll do the reaction and show you what we mean. HCl plus water gives us Cl minus plus H3O plus. The proton that's donated is H, and it goes to the water, and that ends up with chloride and H3O plus. So how it works is if I draw the Lewis dot structure, I got HCl and water, and this electron pair right here is going to go over and grab that proton. You think about it that way. The proton leaves this electron pair behind, and so when we do that, that's when we get, if we leave that electron behind, we'll have the chloride ion. Here's that same electron pair over here. And we'll have H3O plus over here. And here's where that hydrogen comes in. And so I'll yellow this hydrogen here, and that's this hydrogen right here. Although it doesn't matter, but so you can see. And so this HCl donated, the HCl donated a proton to the water. And so the water accepted a proton from the HCl. So HCl is our acid and water is our base. So you can't, you have acid-base reactions. They're all occurring at the same time. Okay, so this learning objective, we only want to learn what makes an acid or not. So how do you recognize these? Well, the deal is it has to be able to accept that -1 charge. You have to have a compound that can give up a proton and accept the -1, making an anion. So things that make anions are really good. Chloride is a prime example. Cl can be, chlorine can become chloride -1. Bromine can become Br -1. Iodine, we know, in ionic compounds likes to be -1. And so these all like to form -1, so they easily can form HCl, hydrochloric acid, HBr, and HI. Things that can form are iodide, bromide, and chloride. Notice that these fluoride, oxygen, sulfur, and selenium, and perhaps even tellurium can form these acids too, but they're not strong. The other three strong acids are nitric acid, HNO3, H2SO4, and perchloric, HClO4. These are called oxy acids, because if I draw the Lewis dot structure for, say, H2SO4, you get one possible dot structure, looks like this. And these protons over here on the left can be donated, and you form the sulfate anion, SO4 -2. So these are coming from anions you memorized in Chem 101, -1, and ClO4 -. They're the only 6 strong acids that you have to know.